Find the following. All right, so in example A, they want us to find f of g evaluated at 3 first, then g of f evaluated at 4, f of f evaluated at 2, and g of g evaluated at 0. So to do composition of functions, you basically want to start with what's considered the first function, and that would be the function that is on the outside here. So when you have f of g, right, take the f function, rewrite it so it has a space. So you'd have like 2 space plus 3. So where the x used to be, there's a space, and then insert what's called the inside function. So it'd be 1 minus 3x squared in this case. And this would be basically f of g of x. And the reason why we say of x is because the function still has x inside of it. And then from there, you could clean it up and do some arithmetic. For example, if I wanted to clean this up, I would just distribute the 2 in, and I would say 2 minus, right? So 2 times 1 is 2, minus 6x squared, and then it'd have this plus 3. And then you could say, well, 3 and 2 make 5, so you had 5 minus 6x squared. And then at that point, we'd have f of g of x, and then we could just plug in whatever x value you wanted to. For example, you could evaluate f of g at 3. And if you did it that way, you'd have 5 minus 6 times 3 squared, right? But that'd be the same as 5 minus 6 times 9, or in other words, 5 minus 54. And that, of course, ultimately gives you negative 49. All right, so that's fine and well, but we could have done this problem even perhaps simpler. And the simpler way to do it would be to simply say, well, if we read this f of g of 3 business as putting the 3 into the g, and then from there putting the result into f, we could actually do the problem that way as well. And then it makes the problem mostly just arithmetic, right? So for example, if I want to do g of 3, I would simply say 1 minus 3 times 3 squared, right? And that's going to end up giving you 1 minus 3 times 9, or in other words, 1 minus 27, or in other words, negative 26. And once you have negative 26, you have the result, and you're going to plug that into the f function. So in the f function, you would say, okay, well, f is basically going to be evaluated at negative 26 now. And so that'll end up giving you 2 times negative 26 plus 3. And if you work that out, you end up with negative 52 plus 3. And of course, negative 52 plus 3 gives you the same answer we found before, which is negative 49. All right, so same solution. I think probably what we did on the right here is a little simpler than what we worked out on the left, although not a whole lot simpler, so it depends on the function, of course. Sometimes it's harder to do the composition, in which case you want to evaluate it the way we just did with the numbers. If it's easier to do the composition, maybe just do the composition once and then evaluate it as many times as you want using the result. All right, either way, that was f of g of 3. Let's do g of f of 4, but let's do it the way we just described a moment ago. All right, so if I'm doing g of f of 4, it means put 4 into f. So let's do that. F of 4 is equal to 2 times 4 plus 3. That's basically 8 plus 3, or 11. And then with the 11, we're going to take that result and then plug it into g. So we're kind of moving this way into the function, right? Into the composition. All right, so we go into g now, and we're going to take that 11 and say g at 11. And that's going to be 1 minus 3 times 11 squared, right? So that'll be 1 minus 3 times 121, and that'll be 1 minus 363. And then, of course, you get negative 362 as your answer. All right, let's do the same thing then for f of f, evaluated at 2. So for f of f, let's do f of x, just to show what that would look like. We would take the f function, and we'd write it with a space, right? So we take the f function here, write it with a space, and then we plug in what's here into the space. Well, that's another f function, so we'll do 2x plus 3 in the space. And then we just go ahead and multiply. We get 4x plus 6 plus 3, so we get 4x plus 9. Now this is f of x, right? Or f of x. And so with f of x, we can basically now plug in whatever we want. We can plug in 2, for example, to see what that is. So 4 times 2 plus 9. Of course, then you get 8 plus 9. And then finally, you have 17 as your answer. All right, let's do the last one, which would be g of 0. So I don't want to do g of 0 the way I just did f of x. The reason why is if I plug g back into itself, I'm going to have to square that function. It's going to be a lot of work arithmetically. a lot of algebra manipulations, right? So I don't want to deal with all that. Instead, what I want to do is simply make it into a very basic problem by saying, let's plug the 0 in first. So I'm going to do g of 0 by plugging 0 into g first and then taking the result and putting it into g. So if I put 0 into g, that would be g of 0, which is going to be 1 minus 3 times 0 squared, right? And of course, this cancels out, leaving you just 1. And so now I take that 1 and I plug it into g. So I do g of 1, right? So putting that back into g and see what I get. It'll be 1 minus 3 times 1 squared. So that's pretty simple. It'd be 1 minus 3 times 1, or 1 minus 3. So finally, negative 2 is my result. So it's a lot easier to do the numerical value plugged into the functions first for the second one, and maybe it was easier to do the actual functions composed and then plug the number in at the end for f of x. All right, so different ways to do the same problem. Both work just fine. Pick whichever one you like the best. All right, let's do the same thing for the example B here. For example B, we're going to start with f of g of 3. So remember what f of g of 3 would mean. It would mean that we would plug the 3 into g first and then the result into f. So 3 into g would be g of 3, which is going to be 2 times 3, which is 6. And then we're going to plug that back into f, right? So to be f now of 6. And f of 6 will simply be the square root of 6 plus 2, or in other words, the square root of 8. You could reduce this to 2 root 2, and that's basically your answer. All right, let's take a look at g of f now. So if I did g of f of 4, again, working with the functions in example B, it means I put the 4 into f and then that into g. So 4 going into f is going to give me basically f of 4, which is equal to the square root of 4 plus 2, and that's going to be the square root of 6. Now I'm going to take that answer and plug it into g, so I'll have g evaluated at the square root of 6. So g here is just 2 times x, so it'll be 2 times the square root of 6, and that's your answer, 2 times the square root of 6. Okay, let's do f of 2 now. So f of 2. Well, again, it's 2 into f, and then the results of that into f again. All right, so f is the square root of x plus 2, so if I do f of 2, I'm going to have the square root of 2 plus 2, which is the same as the square root of 4, and that, of course, is just equal to 2. And then if we plug 2 back into f, we're going to get the same result we found before, right? If this answer goes in here, we're going to get the same answer. We're going to get square root of 2 plus 2, which is the square root of 4, which is equal to 2. So we keep getting 2, right? So if you plug 2 into f of f, you're going to get 2 as an answer. All right, now let's go on to the very last example, which would be the g of 0. So if we do g of 0, well, again, that's 0 into g and then that into g again. So 0 into g is going to be g of 0, which is 2 times 0, which of course is 0. And if you plug 0 into g, you're going to get what? Again, the same result we got before, which would be 0. So we have the answer for the 4 different cases. And that's it for example B.